Next, for introduction, concrete is the most widely used construction material, which is weak in tension and flexural capacity. In the modern construction industry, concrete is being manufactured and used with very compressive strength. To enhance the ductility, energy absorption capacity and strength control capacity, different types of fiber are being used in concrete. Today, the main purpose of construction industries is to make concrete economically sustainable and eco-friendly with a certain amount of desired strength. This study it is aimed to use sheep's wool as a fiber-enforcing material in concrete to investigate the influence of sheep wool fibers on fresh and hardened properties of fiber-reinforced concrete.
So next, for methodology, the apparatus that we use to make the concrete is ordinary Portland cement, then water, coarse aggregate, fine aggregate, and sheep wool fiber. And then we have to do 4 different types of tests for the concrete, which is SLUMP test, compressive strength test, tensile test, and FLEXURAL test. For SLUMP test, we have to clean the internal surface of the mold and apply oil, and then place the mold on a small horizontal non-porous display, and then fill the mold with the prepared concrete mixed in 4 approximately equal layers, then each layer with 25 strokes of the rounded end of the tamping rod. And then remove the excess concrete and level the surface with the trowel, and then clean away the mortar or water leak out between the mold. And then lastly, measure the slump as the difference between the height of the mold and that of height point of the specimen being tested. So, we do the slump test to determine the workability of the concrete. And then next, for compressive strength test, we do this test to determine the strength of the concrete. First, remove the specimen from the water after specified curing time. Take the dimension of the specimen to the nearest 0.2 meter. Clean the bearing surface of the testing machine. Place the specimen in the machine in such a manner. Align the specimen centrally on the base plate of the machine and rotate the movement portion gently by hand so that it touches the top surface of the specimen, and then apply the load gradually without shock. And lastly, record the maximum load and note any unusual feather in the type of failure. And then tensile test. So tensile test is to determine the behavior of the specimen when force stretched on it. So first, we have to make sure the bearing surface of the machine and the loading strip free from dust. The specimen should be weighed in Newton, and place the specimen centrally between the loading strip and ensure the upper plating is parallel to the bottom plating. And then apply the load gradually until the specimen breaks and knock down the value. And then lastly, the same method has been repeated for other samples. Lastly, FLEXURAL test. So we do this test is to determine the force that required to bend a beam. So after prepare the beam, we have to clean the bearing surface of the supporting and loading ruler and remove any loose sand or other material. And then circular roller manufactured out of steel having cross-section with diameter 38 mm will be used for providing support and loading point. And then the length of the roller should be at least 10 mm more than the width of the test specimen. The distance between outer roller should be 3D and the distance between the inner roller should be 3D. And then the specimen stored in water should be tested immediately or removed from water. And then the test specimen should be placed in the machine correctly centered with the longitudinal axis of the specimen at right angle to the roller. And then lastly, the load should be applied at a rate of loading of 400 kg per minute for the 15 cm specimen and a rate of 180 kg per minute for 10 cm specimen.
Characteristic of sheep wool. Based on the sheep wool as a construction material for energy efficiency improvement article by AZZURIN, the sheep wool includes a historical overview of various use. mechanical and physical properties, and its chemical composition as shown in the table above. The major characteristics of wool include fineness, length, crime, color, strength, uniformity, and the amounts of foreign material in wool grades. Some important characteristics of wool are the following. Wool is natural, renewable, and sustainable material. It causes no irritation to the eyes, skin, or lung, and wool fiber present no hazard to human health. Wool fiber are breathable. Wool does not support combustion and will extinguish itself in the event of fire. Sheep wool is static resistant. Wool absorbs noise and reduce noise level. And last one is wool is dirt resistant. As shown in table above, sheep wool fiber reinforced concrete specimens were prepared with different additions for the concrete test. The SLUMP test. The SLUMP value observed after testing all the specimens are represented in figure 3. The SLUMP value of the sheet wool fiber reinforced concrete were too small compared to the normal concrete. Addition of sheet wool fiber caused a high demand of water for making the concrete mixture workable. It was generally happen due to the high specific surface area and fineness of sheet wool fiber. It absorbs more amount of water to come in a flow with the normal concrete paste. Therefore, the workability of concrete decreased. Workability in sheet wool fiber reinforced concrete decreased with the increasing amount of sheet wool fiber in the mix. As observed from the study and the figure 3, the addition of sheet wool fiber beyond 2% was make concrete not workable. This negative phenomenon can be minimized by the addition of superplasticity of required amount. Compressive strength test. The result observed from the compressive strength test is represented in figure 4. It was found 30.77 megapixel compressive strength in the control concrete after 38 days curing. The results show a significant drop in compressive strength after addition of sheet wool fiber in the concrete. Regardless the fiber content and other factor, the larger reduction in compressive strength of sheet wool fiber reinforced concrete was observed for long curing period. It indicated that the strength gaining capability of sheet wool fiber reinforced concrete with curing time is less than the ordinary concrete. Around 5.2% to 79.7% compressive strength reduction observed after 7 days curing of sheet wool fiber reinforced concrete, which the sheet wool fiber contains 0.5% to 6%. In addition, the reduction found for 14 days and 28 days curing time were 14.95 to 77.3% and the 22% to 67.1% respectively for the sheet wool fiber content 0.5% to 6%. As observed in the SLUMP test result, an addition of sheet wool fiber caused a significant reduction in SLUMP value, which found nearly unworkable when the sheet wool fiber contained around 4%. The available water content was not sufficient to complete the full strength gaining reaction of cement during mixture and after casting also. Therefore, the strength dropped unexpectedly. Tensile test. Generally, split tensile strength is greatly dependent on compressive strength of concrete. In this experiment, addition of sheet wool fiber caused a great variation in the strength of change in compressive strength and split tensile strength. The result is shown in figure 5. As observed, initially the addition of sheet wool fiber in concrete caused a decreasing trend in tensile strength of concrete. The cause of reduction is the poor addition and low bond strength between the fiber and cement paste. But beyond 1%, when more fiber were added to the concrete, it becomes stronger in tension. It because the sheet wool fibers start to concentrate together and can take larger tensile load when concrete tends to split under compression. As observed in this experiment, addition of 0.5% sheet wool fiber will resulted a 32.7% reduced tensile strength of sheet wool fiber reinforced concrete after 28-day cutting, where the reduction value show a decreasing trend with further addition of sheet wool fiber, up to 9.2% reduction for 1.5% sheet wool fiber content. Further, the addition of sheet wool fiber was resulting in increased tensile strength, which was observed 44.4% to 32.7% growth of strength than the ordinary concrete for addition of 2% to 3% sheet wool fiber. This trend was also similar for the 7-day and 14 days curing period as shown in figure 5. Thus, the early tensile strength development of sheet wool fiber reinforced concrete is observed much lower than the ordinary concrete. Beyond the optimal level of addition of sheet wool fiber, the agglomeration of fiber made the loss in bonding strength significantly and caused a loss in strength. In accordance with the tensile test result, the addition of sheet wool fiber in concrete should be between 2% to 3% of cement content. FLEXURAL test. FLEXURAL strength of different concrete specimens is shown in figure 6. The result showing that the flexural strength of concrete generally getting improved with addition of sheet wool fiber in it, as well the other fibers do. Up to 20.8% increased flexural strength was observed for the specimen with sheet wool fiber content up to 2%. This increasing trend of flexural strength is prominent for early stage of curing. When the amount of sheet wool fiber in concrete exceeds 2%, the decreasing trend in strength was started. As observed in the flexural test, the crack bridging capacity of fibers are very helpful to enhance the deflection capacity without fracture, which means the improvement in ductility occurs with the addition of fiber. The increased content of fiber is also capable to carry more tensile force along the soffit of the flexural test specimen and bring the cracks up to a reliable limit of load. This enhances the flexural strength with increasing content of sheet wool fiber in concrete. But when the sheet wool fiber content exceeds 3% in the concrete, the reverse result observed. The specimen with 0.5 showing a little drop in ultimate load. This was happened because upon no uniform distribution of fiber which in concrete, which made concrete weak along any specific plane and capacity get reduced. Overall, the flexural capacity of concrete increased with sheet wool fiber content in it. The sheet wool fiber addition level should maintain below 3% to get the best result.
So for discussion, generally concrete characterized by the compressive strength after 28 days of curing. In this experiment of sustainable product, it was revealed that the addition of sheet wool in concrete worsened the compressive strength of concrete, though it is improved the split tensile and flexural capacity to some extent. Therefore, the reason behind this reduction must be need to analyze and proper treatment should address to enhance the performance of sheet wool concrete under compression. As observed from the previous research, any pre-treatment can improve the characteristic of sheet wool extensively, which can be helpful to enhance the mechanical performance. However, in this experiment, the addition of sheet wool causes a reduction in cement content per cubic meter of concrete mixture because there is no ingredients was replaced by the sheet wool. Therefore, the addition of sheet wool takes some space that occupied by the other content of the mixture. If a portion of fine sand can be replaced by the sheet wool, it will not affect upon the content of cement. Therefore, binding action will remain same as the ordinary concrete that will reduce the amount of strength reduction caused by addition of sheet wool, and expecting some increment will also take place. Additionally, some admixtures can be used to improve workability of sheet wool instead of high water cement ratio because it causes reduction in strength.
Last but not least, the conclusion for this presentation is the characteristic of the traditionally used natural fiber are present in sheet wool, making it useful as a construction material. Sheet wool can increase heat insulation and can also be included in plaster mortar. Meanwhile, even a little change can significantly improve the effectiveness of concrete reinforced with sheet wool. Concrete needs to be treated with sheet wool fiber and used according to specific guidelines in order to be more effective as a construction material.